to the early universe and the formation of its first stars and galaxies.
An exciting new chapter in the exploration of our universe.
In some ways, astronomy is similar to the classic board game Clue. Scientists investigate a vast but ultimately contained environment, gathering knowledge and testing theories regarding a large mystery. You can't cover every nook and cranny, but with the right balance of strategy and fortune, you can gather enough clues to make a decent guess at the tidy answer: who, where and how, enclosed in a little yellow envelope at the heart of it all. Only astronomers are attempting to determine the origin of odd flashes of radio signals that reach Earth from the depths of space. What exactly are these unusual radio signals? Are they sent by intelligent aliens attempting to communicate with us? Join us as we delve into the unusual radio transmissions recorded from space by NASA. Astronomers have discovered light signals from the universe's oldest stars for the first time. The discovery of these signals is truly revolutionary because scientists currently know relatively little about the early history of the universe. In reality, they have not uncovered any early universe signals apart from the Big Bang's afterglow. While scientists have worked for years with limited information about the early universe, they do know that after the Big Bang, the universe was a starless, frigid realm made up of radiation-covered hydrogen gas known as the cosmic microwave background. As the early universe's history has remained a mystery, radiation can still be found in space today. Following this phase of nothingness was the Dark Age, a 100 million year period during which thick gas zones formed clumps that ultimately collapsed into the first stars. The hydrogen atoms started to absorb radiation from the cosmic microwave background at a typical wavelength as these gigantic blue stars lighted up the gas surrounding them. Therefore, scientists think that the cosmic dawn may have left an impression on the cosmic microwave background radiation as a drop in brightness in the spectrum, which should be detectable today. Finding this dip has been difficult, as experts have searched in vain for more than a decade. Adding to the difficulty, scientists were unable to establish where in the spectrum they should be looking. The EDGES, a little table-sized instrument, appears to have helped the team solve the puzzle. The antenna was installed in a distant area of Australia where there are few human-made radio waves that could interfere with the transmission. The signal they discovered points to the origin of the cosmic dawn, which occurred approximately 180 million years after the Big Bang. The observed drop was double the magnitude predicted by scientists, which was a startling feature. This suggests that the cosmos was cooler than previously thought because the surrounding hydrogen gas absorbed more radiation than scientists had imagined. According to scientists, this indicates the presence of dark matter, as dark matter is thought to be the cause of the hydrogen gas's loss of heat. If this concept is accurate, it will be the first time scientists have identified dark matter through means other than gravitational effects, despite dark matter accounting for 85% of all matter in the universe. The signals observed have defied many previously held scientific predictions. Given how little we know about dark matter, these findings may help us get a little closer to the reality. However, this was not the only recent astronomical discovery. Here's another mysterious signal from the vastness of the cosmos. Despite the numerous potential sources of radio emissions, astronomers have identified new and unique radio wave signals unlike any before discovered. The radio waves fit no patterns of fluctuating radio sources, but they are coming from the heart of our Milky Way galaxy. The ASCAP radio telescope was used to make the finding. ASCAP is a next-generation radio telescope that incorporates cutting-edge ICT systems and unique receiver technology. It consists of 36 antennas, each 12 meters in diameter, that act as a single device. When ASCAP is operational, it will be capable of high dynamic wide-field imaging with revolutionary phased array feeds, providing a distinct new capacity in radio astronomy. ASCAP's design is unique among radio telescopes since its antennas have 3-axis mobility and will collect and magnify radio waves using phased array feeds, or radio cameras rather than single pixel feeds. Because of these characteristics, the telescope will be able to examine enormous areas of the sky with unparalleled sensitivity and speed. Why did the scientists think this radio wave was distinct from anything else they'd heard? It has a very significant polarization, they explained. This means that its light oscillates in only one direction, which rotates with time. Aside from that, the brightness of the object varies by a factor of 100, and the signal appears to switch on and off at random, unlike anything the scientists have ever seen before. Initially, scientists suspected it was a pulsar or a sort of star that released massive solar flares. However, the signals from this new source do not match those emitted by these celestial objects. While the study on radio wave continues, the source of the signals have been identified as ASCAP J17360.8.2 321635. Despite the fact that the scientists were perplexed by the source of the emission, the discovery was nothing short of astounding. 6 signals were identified by the scientists over a 9-month period in 2020. However, when the scientists used optical telescopes to look for the source in visible light, they found nothing. The Parkes Radio Telescope in Australia came up empty as well. This telescope, located just outside the town of Parkes in New South Wales Central West, is one of 4 devices that comprise the Australia Telescope National Facility. Parkes has a diameter of 64 metres, making it one of the largest single-dish telescopes dedicated to astronomy in the Southern Hemisphere. It began operations in 1961, and since then, the surface, control system, focus cabin, receivers, computers, and cabling have all been modified to keep the telescope at the forefront of radio astronomy. The telescope is now 10,000 times more sensitive than it was when it was first built. However, it was unable to locate the source of the radio signal. Fortunately, there is the Meerkat Radio Telescope in South Africa, which consists of 64 interconnected sensors. A receptor is the entire antenna structure, including the primary reflector, subreflector, and any receivers, digitizers, or other electronics. The core area, which is approximately 1 kilometre in diameter, has 48 of the receptors. Meerkat is more powerful than Parkes, therefore astronomers resorted to it to help them solve the mystery of this odd radio signal. The signal was recognised by Meerkat, but it was irregular and erratic, indicating that the source was very different. Despite being present for weeks in previous ASCAP observations, this source vanished in a single day. Astronomers must now pinpoint the source of these strange signals. They have a list of possible sources to study. First, the radio waves could be coming from a distant star. Stars are one of the few sources that may release polarized emissions, but because their X-ray and radioluminosities are frequently correlated, astronomers expect only detecting X-rays from them. Furthermore, near-infrared emission would be significant and noticeable. Thus, scientists rule out stars because the source does not have a particularly modest ratio of X-ray infrared to radio emission. The next most likely source of this radio emission is a pulsar. So, what is a pulsar exactly? Pulsars are interesting spherical compact objects the size of a large city, but with the mass higher than the Sun. However, they are not stars, or at least not live stars. Pulsars are neutron stars, which develop when a star more massive than the Sun runs out of fuel in its core and collapses in on itself. This celestial death is generally followed by a gigantic explosion known as a supernova. A neutron star is the dense nugget of material that remains after this violent death. Despite its allure, pulsars were not found to be the source of the ASCAP J17360.8.2 321635 radio emission. Why? This is owing due to the source's lack of pulsed emissions. It's most likely a pulsar with a lot of scattered energy, an ultra-long period, or a pulsar in an eccentric binary system. However, it does not appear to be a conventional pulsar. A magnetar is another possibility. What exactly is a magnetar? It's about magnets, as the name suggests, but on a massive scale. If a magnetar is positioned halfway between the Earth and the Moon, the effect will be felt by everyone on the planet, since all credit cards on the planet will be wiped. If you were to come within 600 miles or 1,000 kilometers of a magnetar, you would die quickly because the magnetic field would destroy your body, ripping electrons from your atoms and turning you into a cloud of monatomic ions, which are single atoms without electrons. But that's not the only weird thing about these strange objects. magnetars produce enormous amounts of energy in the form of flares, X-rays, and gamma-ray bursts. As a result, they are linked to extreme events in the universe, making them the strangest phenomena in the universe along with black holes. So what ruled out magnetars as the source of this radio signal? Magnetars, on the other hand, have relatively flat spectra, which indicates that the strength of emission does not vary considerably with frequency. This contradicts the source's observable nature. Periodicity searches using a meerkat disqualify magnetars, which have typical intervals of 1 second to 10 seconds. However, there is a probability that it is a one-of-a-kind ultra-long period magnetar that has to be investigated further. Another possible source of the radio signal is a galactic center radio transient, or GCRT. In fact, this one seems more credible. The spectra of GCRTs are steep, highly polarized, and do not emit X-rays. However, just 3 galactic center radio transients have been found, and their sources, if they are even the same, are unknown. Furthermore, the timescale on which the emission varies for ASCAP J173608.2321635 does not match the time periods of other galactic center radio transients. The source of this radio wave is still a mystery that experts are eager to solve. So where do we go from here? The experts intend to keep a close eye on the object and use the tools at their disposal to look for additional clues as to what it could be. However, assistance is on the way, which may speed up their work and provide many new ideas. Within the next decade, the Transcontinental Square Kilometre Array Radio Telescope will be operational. This project is an international collaboration to build the world's largest radio telescope, with a collecting area of more than a square kilometre. The size of the SKA represents a significant advancement in both engineering research and development toward producing and delivering a one-of-a-kind instrument, with full design and planning presently well underway. Astronomers believe that the capabilities of this telescope will help humanity solve mysteries like the latest discovery, while also opening up large new areas of the cosmos to study in the radio spectrum. Let us know what you think of this unusual radio signal in the comments area below.